Imagine you wake up one morning and the sun is shining twice as bright as yesterday. Not slightly brighter, exactly twice as bright. That means the Earth is receiving twice as much solar energy as usual, every second. Right now, the Earth receives about 1,361 watts per square meter of surface from the sun. That is called the solar constant. Double that number, and you get 2,722 watts, hitting every square meter of the planet simultaneously. That is like placing a powerful space heater on every single square meter of Earth's surface and switching them all on at once. The countdown has started. You have 24 hours. Hour 1. The atmosphere begins reacting immediately. Air near the surface heats up faster than it can dissipate heat upward. Temperatures in equatorial zones, which receive the maximum solar radiation, begin rising at several degrees per hour. That sounds slow until you remember that heat stroke in humans occurs at air temperatures of around 40 degrees Celsius, combined with high humidity. If the starting temperature in the tropics was 35 degrees, within 2 to 3 hours it crosses the critical threshold. At the same time, the temperature difference between rapidly heating equatorial zones and more slowly responding polar regions creates sharp pressure gradients. The atmosphere starts moving more aggressively. The first new storm systems begin forming over warm oceans. By the end of hour 1, meteorologists around the world are staring at their screens, unable to explain what they are seeing, because nothing in their models has ever looked like this. If you think hour 1 sounds like just a hot day, subscribe, because hour 3 changes everything. Hour 3. The surface of the planet begins to burn, literally. Wildfires ignite simultaneously around the world in regions where vegetation was already dry. California, Australia, Siberia, the Amazon, all of it catches within a matter of hours. But these are not ordinary wildfires that get put out by air tankers. These are fires burning in air temperatures that are already dangerous to humans, driven by winds intensifying from pressure differentials, and humidity that is plummeting from intense evaporation. Asphalt in cities begins to soften. The melting point of bitumen used in road surfaces is around 50 to 60 degrees Celsius. In equatorial cities, that temperature has already been reached on road surfaces. Animals in the wild instinctively seek shelter and shade, but shade no longer helps because the air itself is too hot. The first human fatalities from heat stroke are recorded in hospitals across tropical countries. Air conditioning systems are running at maximum capacity, and power grids begin overloading from unprecedented demand. Hour 6. Water starts behaving in ways it should not. The surface layer of the oceans, which normally heats slowly and stabilizes the climate, is now receiving twice its usual energy input. Surface water temperatures in tropical zones rise by several degrees in a matter of hours. That is catastrophically fast for marine ecosystems. Coral reefs, which die from temperature deviations of just 1 to 2 degrees over the course of weeks, are now facing changes of several degrees in hours. Fish dive deeper, searching for cold water. Massive evaporation from ocean surfaces sharply increases atmospheric humidity, which creates a greenhouse effect on top of an already overheated atmosphere. Heat is literally being trapped at the planet's surface. Rivers in hot regions heat to temperatures at which freshwater fish die. Drinking water in unprotected reservoirs turns hot. By hour 6, water supply infrastructure across tropical countries is operating in emergency mode. Hour 12. Half the day is gone, and the planet has reached a state that has never existed in human history. The average global surface temperature has risen approximately 8 to 12 degrees above normal. That is greater than the difference between today's climate and the last ice age, except in the opposite direction, and achieved in 12 hours instead of thousands of years. The hurricanes that began forming in hour 1 have now grown to categories that do not exist on any current scale. The Saffir-Simpson scale ends at category 5, with wind speeds above 70 meters per second. Some of the systems now forming already exceed that limit. Power grids around the world are overloaded and begin cascading offline, first in the hardest hit regions, then in sequence across connected networks. Transportation is paralyzed. Aviation is grounded due to extreme atmospheric conditions. Communications are disrupted. Governments declare states of emergency one after another. Civilization as a functioning system begins shutting down piece by piece, not from an explosion, but from overheating. Hour 24. The sun returned to normal. Brightness dropped back to its usual levels. Instruments at solar observatories show normal readings. But the planet looks at those instruments and cannot make sense of them, because what is happening on its surface has nothing to do with normal. Start with fire. The fires that ignited in hour 3 did not wait for the sun's permission to stop. By hour 24, the Amazon, Siberia, Australia, Central Africa, and the western coast of North America are all burning simultaneously. The total area of active fires is several times greater than any year on record. Smoke from these fires rises into the stratosphere and begins to settle there, exactly the way it did after large volcanic eruptions. Soot particles in the upper atmosphere block a portion of incoming sunlight. This means that after a day of extreme overheating, the planet enters a period of partial dimming. Temperatures in some regions will begin falling below normal, from fire, literally, into cold. Agricultural regions that survive the heat will now face unseasonal frosts. Crops that did not burn will freeze. The oceans recover slowest. The surface layer of water that overheated over 24 hours will release that heat back into the atmosphere for months. This means hurricanes will continue drawing energy from warm water and remain active far beyond the normal season. The Atlantic and Pacific hurricane seasons of this year will break all records, not because the sun is still brighter, but because the ocean has become a massive heat battery discharging through storms. Insurance companies around the world will declare bankruptcy one after another. The scale of damage from a single hurricane season will exceed the total reserves of the entire industry combined. Marine ecosystems. The corals that died in hour 6 will not return in a month or a year. Major reef systems, the Great Barrier Reef, the Caribbean reefs, the reefs of the Indian Ocean, recover over decades under ideal conditions. After what just happened, conditions will not be ideal for a very long time. Fish populations that lost their habitat and food sources will collapse sharply. This is not an abstract environmental problem. It is a direct blow to the food security of 1 billion people who depend on seafood as their primary source of protein. Infrastructure. The power grids that cascaded offline in hour 12 do not switch back on like a light switch. Restoring large power grids after a systemic failure takes days to weeks, even under normal conditions. After transformers and substations burned out from extreme overload, it takes longer. High-voltage transformers are not mass-produced. Each one is custom-built and delivered over months. In some regions, restoring electricity will take not weeks, but months. Without electricity, there are no refrigerators, which means no food preservation. No pumps means no water supply. No communications means no coordination of recovery operations. How the world recovers. The first 3 months are a global, simultaneous emergency response unlike anything in history, because previous disasters were regional. This one hit everyone. Food reserves are redistributed through international organizations. Military forces across many countries shift to humanitarian operations. Restoring power grids becomes the top priority because, without electricity, nothing else is possible. The next 2 to 3 years are a fight against consequences the sun started but did not stop. The fire smoke in the stratosphere gradually settles, but while it is there, agricultural regions receive 5 to 10% less sunlight than usual. Crop yields fall worldwide simultaneously. Food prices rise. Countries that depend on food imports find themselves in the most vulnerable position. Political instability in those regions increases. History shows that food crises are one of the primary triggers of social upheaval. 10 years later, the planet has externally returned to something resembling normal. The fires are out, the grids are restored, hurricane seasons have normalized. But climate scientists see a clear signature of those 24 hours in the data. Global average temperature is slightly higher than it was before that day and will not return to its previous value. Marine ecosystems have partially recovered where conditions allowed. Where they did not, empty reefs remain as a reminder of one day when the sun decided to test how fragile the system we call home really is. Physics gave its answer. More fragile than we thought. If you want to see more breakdowns like this, hit like.